Алло, Павел.
Да,
Все, вы готовы?
да, я готов.
Всё, отлично. У вас примерно на сколько презентация будет минут?
Минут на 50.
На 50, отлично. Если сможете, на часик, там можно чуть подольше даже.
Ну, возможно, даже растянется, да.
Все, отлично. В принципе, можете начинать. Сейчас люди еще будут подходить.
Мгм.
Все.
Так, давайте проверим. Презентацию видно будет.
Да, давайте.
Видно, да?
Да.
Так, что, могу начинать?
Да, ваш камера. Можно вашу камеру?
Конечно. So,
Ага.
okay, let's start. Hello, everyone. I'm Pavel. Today, I would like to talk about how we automated product localization across more than 60 languages without dedicated team of translators. And couple words about me. I'm not professional translator. I'm definitely not a linguist. In fact, before this project, I had very little experience with localization at all. I'm just a backend engineer. At some point, one of my responsibility was to make product localization work at scale. In this talk, I would like to show how modern AI approaches make it possible. For example, for a single developer to accomplish what previously required an entire team. But I will also talk about challenges we encounter as we dive deeper into problem that at first glance seems like something AI should be able to do end to end, but it turns out to be much more complex in practice. And how it may be useful for you, especially if you have plans to start your own project and your resources is very limited. Before talking about architecture and AI-driven approach, I would like to provide some context around the problem. I work on travel product that operates across many markets and need to support large number of languages, more than 60 in our case. When I talk about localization, I'm primarily referring to static translation. This is the piece of text which are embedded in the code base and stored in repositories. And we are not just talking about website interface. We also have backend services, web frontend, iOS application, Android, email, and push notifications. And all of these platforms are constantly evolving. And every week brings new feature, new screens, new user-facing messages, and of course, new texts that need to be translated. In early days, localization for us felt like just another item in backlog. But once the number of languages grows into the dozens, simple questions start to appear. How do you keep all of this up to date without building dedicated team and case specialists? And perhaps even more, especially for us, how do you do it without slowing down releases? Um, let's look how localization was typically handled before AI. For most teams, story starts in every similar way. There is a primary product language, then English is added. In many cases, that's where localization stops. Sometimes a few additional languages introduced for key markets. At this stage, everything seems fairly straightforward. There are not many translations, they can be maintained manually, and developer can update translation for their own platforms when it needed. It's actually quite simple, but as the product grows, the situation changes very quickly. Each new language is no longer just another translation file. It's another set of language-specific rules, edge cases, and cultural nuances that need to be taken into account. And with every new language, this becomes a little harder to maintain. The most painful part is that localization gradually becomes part of the critical release path. For example, when developers ship new feature, they also introduce new user-facing text. That text needs to be translated, reviewed, or validated. Only after that, release can move forward. As a result, you end up with a situation where the code already finished, feature has been tested, everything technically ready for production, but release still blocked because translation are missing. That situation what we faced many times. At that point, we realized that we need infrastructure for localization. We need system that could handle localization automatically, and that's when we start thinking about building our own solution. But of course, before building our own, we spent quite a bit of time looking at the option that already existed. We look at how other companies solve this problem and what tools were available on that moment. So let's take a look at these options and why they didn't satisfy us. First, we had no intention to build our own localization platform. Like most teams, we wanted to use something that already existed. After all, localization is not a new problem, and many companies have been solving it successfully for years. So what option we did consider? Well, first option was to do nothing at all and rely on built-in browser translation. At first, this sounds like a good idea. Modern browsers can translate web pages reasonably well, but it quickly become obvious that this only works for a subset of users and only for web platforms. Different browsers use different translation engines. Some users prefer Chrome, some Safari, some don't use automatic translation at all. And even if browser translation worked perfectly, it wouldn't help with mobile application and emails. So the solution was fundamentally incomplete. The second option was to adopt translation management system, TMS, such as Crowdin, Localize, Phrase, and similar platform. And honestly, this was much closer to what we were looking for. This platform do a great job of managing translation, languages, workflows, and collaborating with translators. However, historically, they were built around human-centered process, where most of the translation and validation work is performed by people. Typical workflow looks like something like this. Developer adds new text, translation resources uploaded to the platform, translation tasks is created, translator produce translations, some reviewers, some approve it. Only after that, changes may get back into product. But to be fair, modern TMS platform have evolved significantly, and now they also integrate AI capabilities as well. But at their core, the system still work same way. The process is still but around people, and that wasn't really what we wanted. Our goal was to minimize human in localization workflow as much as possible. Next option, and most obvious, now just send everything directly to ChatGPT, Cloudy, Gemini, and so on. And to be honest, that's where many teams start today. The problem is that the limitation of this approach become visible very soon. The first issue is cost. Translation files can become very large, which means significant token consumption. The second is context management. Yes, LLM has improved significantly, but sometimes localization files are simply too large even for modern LLMs. But the much bigger problems lies in everything that is not related to the translation itself. Question like, how do we detect added case, outdated case, how we synchronize repositories, how we validate quality, and so on. LLMs couldn't solve for us. Because LLMs very good at translation text, but they don't solve infrastructure problem on their own. At least you still need right workflows and process around them. But before talk about AI, let's first look how our system is designed. So our goal was to build systems that could manage entire life cycle automatically. This means tracking which translation key have been added, which key have changed, which keys are no longer used, and which platform need to be updated. In the end, the architecture turned out to be relatively simple, even though it consists of several distinct stages. About them. First, process starts by scanning a repository for new or modified keys. All detected changes, then normalize it into common format and store it in centralized repository based on PO format. It's just a static files. We will talk about it later. Next, AI translation pipeline is triggered, and once translation are generated, system runs series of automatic validation checks. After validation, platform-specific artifacts generated automatically. Finally, we generated changes and committed back to appropriate repositories. At that point, localization is no longer a separate process. It's simply another automated stage in the software delivery pipeline. And this leads to the next question. If we have backends on Go, Python, web application written on JS, Android, iOS, how should translation be stored? Where should they live? And this is exactly where PO becomes core of our infrastructure. Why PO files? When it comes to storing translation, every platform tends to use its own format. On backend, you might find JSON, YAML, or various custom formats. Front-end application often store translation in TypeScript files. Android uses XML resources. iOS has its own localization bundles. If you try to work with each format independently, you quickly end up with complex system full of integration, converters, and duplicated logic. So one of our first architecture decision was to establish single internal representation for all repositories. We choose PO format, also known as portable object. It comes from GNU GetText ecosystem and has been used for decades to localize all kind of software. Simple example looks like on slide. But the real value isn't the syntax itself. What matters is that the format natively supports plural forms, translation context, translator and developer comments, source code reference, and various metadata attributes. It doesn't matter where localization key came from. It could came from anywhere. Go, Python, React, whatever. Once it entered in the pipeline, it always represented in exactly the same way. In practice, PO became the internal language of our entire localization platform. All parsers convert data into PO. All translations workflow operates with PO, and all validation check work with PO. And only at the very end, we generate files required by each platform. This gave us single source of truth and very simplified overall architecture. At this point, we had solved infrastructure problem, but we still had deal with translation themselves. And that's where things get much more interesting. But there is another important point. A few years ago, building a system like this would have been almost impossible. So what changed? Let's take a look what made this approach possible. Looking at the architecture, a reasonable question might be what actually new about it and what advantages it provides. After all, localization formats have existed for decades. PO files have been around for decades, CI/CD, nothing new. Automated repository scanning, it's also not a new idea. The reality is that for a long time, the main limitation was translation quality itself. How we started? Initially, we built system on top of traditional APIs such as DeepL and Google Translate. And to be honest, the experience wasn't great. We often had problems with placeholder formatting or special characters were lost during translations. We couldn't translate a large block of text, but then the first generation of LLM arrived. Models like GPT-3.5 already performed much better at translating individual sentences. But as soon as translation required more complex context, quality dropped significantly. We even experimented with self-hosted open source models and fine-tuning, but in practice it turns out to be more expensive, slow, and difficult to maintain. And translation quality wasn't great. The real turning point came with GPT-4 and next generation models. For us, three things changed dramatically. First, it's context understanding. Models stopped treating text as isolated string. They became capable of understanding surrounding context and meaning behind it. As a result, translation quality improved significantly, especially for longer and more complex text. Second, it's formatting and placeholder. Real-world localization rarely consists of plain text. Almost every row contains things like placeholder, HTML tags, special symbols. Early models often broke these structures. They would remove placeholders, reorder them incorrectly, or place them into wrong position. Modern models are much better to handle these cases. Third, it's context window size. This turned out to be much more important than we initially expected. A larger context window made it possible to translate entire localization files in a single request. This became especially valuable when launching new language, update large number of translations, translating large email templates, translating content-heavy pages and blogs. And it was a combination of these three factors that made our approach possible. For us, AI became the main translation tool rather than just an assistant. However, the story doesn't end there. Even modern LLMs still make mistakes. And in many cases, those mistakes happen for the same reason as before. Getting right context to the model is still a challenge. Let's look at a very simple example. In travel products, we often need to translate hotel-related localization keys that consist of just one or two words. Imagine we have a button labeled book, and how should it be translated? Is it a noun, meaning physical book, or is it a verb, meaning to make reservation? Or consider another common example, OK button. In different language and context, it might mean accept, confirm, complete, continue. For a human translator, this is usually obvious. They can see surrounding UI and quickly understand what the text means. But what should an automated translation system do? In early version of our platform, this kind of mistake happened quite often. The reason was actually very simple. We were translating individual strings. Sometimes that worked, sometimes it didn't. The biggest problem appeared with ambiguous words, short button label, navigation elements, abbreviation, and domain-specific terminology. And as I mentioned before, we didn't want to solve this by introduce more manual work. We didn't have dedicated team of translators. The whole goal was automate the process as much as possible. So, as Element proved, we gradually changed our approach. First, we stopped translating individual string and start translating group of related keys. That gave the model more context and quality improved significantly. Then we moved to translating larger section of PO files. Later, as context window continued to grow, we began translating entire files at once. Instead of seeing single words, the model would now see something like this in the center of screenshot. Search hotel, destination, check-in, and so on. At that point, translation quality improved significantly. Because the model could finally understand that it was operating inside hotel booking interface, like on right picture. However, that approach had limitation. Translating entire files worked very well when launching completely new language. But more often cases when the developer adds single new key and that key needs to be translated into dozen of languages. And processing huge files by LLM only for one key becomes very expensive. So we introduced another workflow. When developer adds a small feature or introduces few localization keys, the system first generates translation for only one language and only for those keys. Importantly, this is language other than English that the developer understands well and can validate personally. Usually it's a native language for developer. Developer reviews diff in PO file, if necessary adjusted, and if developer satisfied, he triggers the full translation pipeline. From that point, validated translation is used together with English text as additional context for generating all remaining languages. The developer is no longer involved. This approach significantly improved translation quality without requiring us send large amounts of context every time when we made small changes. But even if model understands the meaning correctly, that doesn't mean that translation is ready to use. Because translation is not just about meaning. Every language comes with its own grammatical rules, formatting requirements, and linguistic edge cases. The next challenge was dealing with complexities of individual language themselves. At this point, it might seem that major challenges have already been solved. We have automation, we have AI-powered translation, we have context. So what's left? In reality, this is where some of most difficult problems begin. Because language differ not only in vocabulary. Let's look at a few examples. Plural forms. In English, things are relatively simple. One guest, two guests. There are only two forms, single and plural. But in Russian, already introduced additional variation. Now, new correct form depends on number in much more complex way. And Arabic goes even further. It uses 6 different plural categories. As a result, single translation key may require multiple translated variants. And yes, there are cases where LLMs choose the wrong plural forms or even generate wrong numbers of forms entirely. But pluralization, it's only part of problem. Some languages are written from right to left. For example, Arabic, Hebrew. In these cases, translating the text is not enough. The entire interface may need to adapt. Things like alignment, element positioning, navigation, and behavior of certain UI components. This was not only a localization challenge, significant amount of work was done by our front-end and mobile teams, who had to introduce retail support into already mature and fairly complex product. And as you can imagine, that came with its own set of problems. That's why it's important to start localization early as much as possible. Another challenge, punctuation and Unicode. There are also less obvious language-specific details. For example, Chinese and Japanese often use punctuation that looks like very similar or even identical to Western punctuation. However, underlying Unicode characters are completely different. This difference is extremely difficult to spot visually. And they can affect on rendering, validation rules, text processing, and even search functionality. And some example even more surprising. In Greek, the character semicolon is actually used as a question mark. Small details like this can unexpectedly break templates, parser, or internal validation logic. If the system assumes that punctuation behaves in the same way in every language. And yes, this caused bugs in our system as well. Text expansion. Another challenge is text length. Different languages can vary dramatically in size. German is one of the most common examples. Translated text in German often significantly longer than English equivalent. Because of this, UI designers and front-end engineers typically recommend reserving around 30% additional space for localized elements. Otherwise, button menus and layouts can start breaking as soon as new language are introduced. So, localization is much more than translating strings. It's a combination of linguistic, user interface, language-specific rules, and automated validation. Translation is only one piece of this puzzle, but even if we solve it context, plural forms, and language-specific challenges, one important question still remains. How do we actually trust translation generated by AI across so many languages? This is a very important question because reality is that you cannot fully trust an LLM in production. Everything may look perfect on one or two examples, but once you're dealing with tens of thousands translations, mistakes start to appear. And we run into them all the time. At the time, manually reviewing everything is not realistic for us. So we quickly realized that we needed multiple layers of validation. Layer 1. The first layer is LLM itself, which generated translation based on context we provide. Second, it's code check. After LLM translation is generated, we automatically verify PO structure, required plural forms for each language, placeholder preservation, special characters, punctuation, formatting rules. These checks catch surprisingly large percent of problems. However, technical correctness doesn't guarantee semantic correctness, which brings us to third layer. As I mentioned earlier, the developer validate translation only in language they actually understand and it's native for them. After that, they approve it. Layer 4, it's targeted QA. Final layer is release validation in pre-prod system. But even here, we do not attempt review every language. That would be impossible. Over time, we collected enough production experience to understand where problems are most likely occurs. And those areas typically include RTL language, language with large text expansion, language with complex rules. Instead of checking everything, we focus only on high-risk areas. In the end, our approach becomes surprisingly simple. LLM plus code checks plus developer review plus targeted QA. That combination allowed us to eliminate a huge amount of manual work while maintaining translation quality. And most importantly, localization stopped being release bottleneck. And also, I wanted to add a few words about keeping translation up to date. The problem is that many localization systems treat translation as a static artifact, but products are constantly evolving. Text changes, messaging changes, business requirement change. Imagine a feature has already been translated into tens of language. For example, we had button with text book now and send 20%. Everything looked good. The translation correct across all languages. But a week later, business updates rules and deliver changes the English text. Text now looks like book now and enjoy free breakfast. Now we have a problem. If your product only support English, users simply see updated English text. But once you support tens of languages, things become much more complicated. The old translations are still here. Users in German, French, Arabic, and other language may continue to see outdated messages, and it's a bad user experience. And that's exactly why one of the key responsibility of our localization platform is detecting when translation is no longer valid. The system automatically invalidate translation for all other languages and mark key for retranslation. As a result, developers never have to think about localization. They simply update text and code. After that, everything else happens automatically. But changed case are not only part of problem. There are also issue of dead translations. Over time, every product accumulates removed screens, deprecated features, renamed keys. If nothing is done, translation repository slowly fill up with unused content. So during every scan, we don't just look for a new case, we also track deleted ones. If localization key is no longer referenced anywhere in codebase file, the system automatically removed from localization repository. Another important aspect is key uniqueness. We avoid reusing the same localization key across different parts of the product. Because two pieces of text may look identical today, but evolve in completely different directions tomorrow. And once a shared key has spread across multiple screen, services and platforms, changing it became painful. To avoid this, our parsers generate unique identifiers automatically and track the origin of every translation key. As a result, localization stopped being collecting of translation files. Instead, it becomes living system that continuously synchronizes itself with product's code base. And that's what allows us to keep translation up to date without manual maintenance or additional operational process. But final question is, what was actual business impact? Did all of this complexity pay off? For us, the answer is yes. Interesting. The biggest benefit wasn't the cost of translation itself. With modern LLMs and our optimization to reduce token consumption, translation has become almost free. The real value came from solving our biggest operational pain point. Translations stopped delaying releases. That turned to be more important than reducing translation cost. Before automation, localization was almost always part of critical release path. Another major benefit was scalability. We gained the ability to support more than 60 languages without continuously growing the team. But if summarize, our goal was never to build perfect localization platform. It's already existed. Sometimes the hardest part of the optimization is knowing when to stop. Approaches that look cutting edge today can become outdated surprisingly quickly. Our goal was to solve real business problem, and we did. The system has been running in production for almost 2 years, and now it's continued to deliver value. But honestly speaking, today we start experimenting with AI agents, tools like Claude and new approaches to orchestration pipeline. The long-term goal is obvious: to remove even more manual steps from process and eventually eliminate developer involvement from translation workflow altogether. But that's probably topic for another talk. And final thoughts. If I had to build system like this again, knowing everything I know today, there are few things I would start thinking about much earlier. First, if you're confident that your product will eventually need to support many languages, don't postpone localization until later. Start early. Even if it's just a single repository. Once you have the infrastructure, workflow, and validation process in place, extending localization to additional platforms becomes much easier. Second, and this is especially relevant for front-end and mobile engineers, plan for text expansion from the very beginning. Good rules of thumbs to respective around 20-30% more space than English text requires. You will thank yourself later. Third, don't leave difficult language until the end. Start experimenting with languages like Arabic, Hebrew, Chinese, Hindi as early as possible. The sooner you encounter the challenge they introduce, the sooner you will understand how your product needs to evolve to support them properly. Another lesson is not to be afraid of building your own solution. A few years ago, default advice was usually to buy existing software and adapt your process around it. Today, the situation is different. With modern AI assistant development tools, if you understand the problem deeply enough, building solution tailored to your specific needs can sometimes be faster and simpler than integrating large third-party platform. Of course, that doesn't mean that you should always be build instead of buy, but trade-off have changed significantly. And finally, AI will not solve all your problems. As you can see, problems that initially looked easy to solve with AI turned into much larger engineering effort. It can automate large part of workflow, but you still need to understand the domain. You still need to understand edge cases, and you still need to design system around those realities. AI is very powerful tool, but it's not substitute for understanding the problem you're trying to solve. Thank you. Any question?
Так, сейчас вы сможете еще рассказать примерно на 20 минут что-нибудь?
К сожалению, я, наверное, прогадал с таймингом.
Ну, можете что-нибудь от себя добавить, что угодно, что хотите.
Да, ребят, это будет сложно. Если есть какие-то вопросы, я бы смог ответить.
Ребят, есть какие-нибудь вопросы у вас? Вот я вижу вопросы задали в чате в Zoom. Вы их сможете посмотреть или вам прочитать?
Окей. Спасибо. What's the difference is between translation and localization? Translation is simple. You just translate one text to another. For example, our browser can translate our website. That's translation. You just translate all web interface as you see to another language. But localization, it's complex approach, and you need to localize all your repositories. You need to localize all system messages, and also not only static files. You need also localize all content which you have in your project. And that's another big problem which I haven't covered in this speech. It's talk for another topic. What's the biggest challenges of localization AI products for global markets? It's earlier it was resources. Now, of course, it's we shifted this problem from translators and linguist sites to engineering sites. And now major problems is engineering experience and experience with AI products, if I answered. How can I help localize websites and mobile application at scale? As I mentioned, our system scan all our repositories and mobile and web and backend. It doesn't matter what actually repository. If developers follow our workflow and introduce new case in right way, our system process it, and then nothing changes. As I previously said, everything converts in PO format, and then usual pipeline works with PO files. How companies ensure culture accuracy when using AI for localization, and what industries benefit? AI localization. What benefit from AI localization? Of course, it's reducing costs. Well, first of all, it's reducing costs on third-party solutions like Localize or Crowdin, because it's not free solutions. And second, of course, it's reducing cost on team. You don't have to maintain entire team with translators or outstaff it. You can manage by your developers. Um, how can startup completely globally using a powered localization tools? Oh, sorry, I didn't understand this question. How startup completely com compete globally using okay. Oh, I don't think that it's area for compete among startups. It's just one of tools which startup use uh, for scaling themselves to global audience, and that's all. Uh, what do you think a localization will look like in the next 5 years? Oh, uh, in my opinion, mm, we will stop do anything manually and everything will do AI agents. We already experiment with this, and some part of our system we already migrated to agentic system, but we need to collect more edge cases which we haven't covered, and then it will possible to localize without human works at all. And I think in future we will not think about localization. Some tools or some AI workflows will appear and will solve this problem completely. Any questions?
А вот лично из вашего опыта для меня личный вопрос. Как использование помогает условно, в повседневной жизни?
В повседневной жизни в работе при разработке или в обычной жизни?
Можно, наверное, даже и в разработке, и в повседневной жизни, условно, из вашей жизни. Можно ответ на английском, просто у меня формулировка на английском не очень хорошая. Я вот
Окей,
вам решил задать такой вопрос, а слушать я могу.
окей. How it helps in usual work routine? Well, of course, it's speed up all process, and I always don't use resources like Stack Overflow and etc. For finding some solution of my problems or my questions. Of course, AI and chats can answer almost on any problem what I have. And from another side, of course, modern code agents, AI coding agents, help significantly. And usual cases, you can cover almost 100% without coding by yourself. But major problem is to review it. If you don't know problem deeply, you can skip important details and AI will not help you. It's very important to review it or do it more than one time, repeat and repeat for cover all problem edge cases, and only in that case solution will be worked and it will be safety, because we already face it with so many cases when especially junior developers broke production because they just generated code without understanding what actually it have to do. And as if I answer in my regular job, it helps significantly, but I can say that AI do everything for me. It's not true, and still maybe not part of coding job, but most time when I'm thinking, when I'm finding solution, I do by myself. I just additional assistant.
Спасибо за ответ. Можно вот еще один вопрос на русском, а мне ответите на английском?
Окей.
Как учитывать культурные особенности разных стран при работе с ИИ? Такой у меня вопрос. Я вот сайты просто пишу иногда, вот, и хотелось бы переводить их сразу как-то для разных стран, для разных культур, вот как, как это помогает, как учитывать.
First of all, you need to define what languages you want to introduce. If it's tens of languages and all possible languages, then you need to do it step by step, because any new, not language, but group of languages, they introduced new rules and new edge cases. And of course, you need to understand how to deal with it, because even RTL languages stopped us very significantly. We stuck on interfaces problem, we stuck on validating such languages, and I think it was most challenges for us. But anyway, other languages can bring new features in your design or in behavior of your UI elements, because what what usually we use for our usual needs in interface maybe not fit for another culture and people who talk on another language, completely another, I mean, like Hindi or Arabic. And of course, you need to do some job before start to code this task. It's very important to deeply understand what problem is. Something like that.
Спасибо за ответ. Вот у нас еще в чате люди позадавали вопросы. Ответите на них, пожалуйста.
Okay. What's the risk of relying entirely on machine translation? As I said, first of all, you need to check it carefully and, of course, cover it by code check. It would be better because you can rely on AI in production, and especially you can rely in one cases or two cases. It can work perfectly. And you can decide to deploy it in production. But in production, it's happened like that I don't know, 100 case can broke everything. And what we use also, we use additional agents checking. Like one AI agent can check another AI agent. One agent helps you write code, another agent helps you review code. Of course, you review by yourself, but another agent helps you. And it helps to cover most of the problem. And of course, you need to understand all row of code, what you deploy to production. If it mature project. Of course, if you are doing startup and for you more important speed, and maybe you can allow some mistakes in production, then it's okay. But if it's mature product, you have to check it as much as possible. Next question. How can I localization support accessibility and inclusion? And, I can't understand questions, sorry.
Возможно, он имел как в виду, как AI локализация помогает accessibility and inclusion.
Я понимаю перевод, но я не понимаю смысл.
Насколько ИИ помогает доступности, скорее всего. Видимо, мы неправильно сформулировали вопрос.
Нет, так как
Sorry, I can't understand question.
Я думаю, я понял перевод. Возможно, как ИИ может помочь, как локализация может помочь людям, условно, с ограниченными возможностями.
Okay. Today it's already existed some solution which can convert some user interface text and all interface to the speech. For example, if people have some limitation with eyes, for example, and yeah, that exists, and of course this can happen. But how to use it in your own projects, I really didn't have such experience. I know such projects, but I can say something more about it.
Можно вопрос еще от себя, пожалуйста, добавлю? Как вы определяете приоритет языков при выходе на новые рынки?
Yes, it's a good question. First of all, we try to cover all language group. For example, if we start work with Slavic languages, then we need to cover all Slavic-like languages, like Russian, like Ukrainian, Belarusian, and others. Because rules vary closer, I mean language rules and language specific. Next point, it's business decision. Of course, business decide what next language group or just a language and then all language group will be opened and what market we want to cover. And of course, we have priority with languages. Of course, English, German, French language, which more widespread in the world, Spanish, they have highest priority for us, and we try to check them more carefully than others. We can allow ourselves maybe not to be so care with some language like, for example, Hindi or any other language which not in priority with our business. But of course, we try to, with the eye, we try to cover not cover, but solve all problems in each language as much as possible. Because when you solve one group of problems in one group of language or one language, you can scale it to in other languages, and it gives it increase quality of all product.
Спасибо за ответ. А можно вот последний, наверное, на сегодня вопрос от меня, и, может быть, кто-нибудь из чата еще захочет, но у меня такой вопрос. Как работать с языками, для которых доступно мало обучающих данных?
That was a problem, especially in first version of LLMs. For example, GPT 3.5 was good at English, was good in German and closer languages, but it was bad in Russian, for example. And really, I can advise how to deal with it for small teams, because it's very hard to support. It's very hard to collect enough data for manage with LLM learning for your translation needs. But there are some on some resources like Hugging Face, there are many libraries which cover exactly one language, and you can combine it. If you couldn't find some exotic language, you can, or for example, ChatGPT or another famous LLM can manage with that. You can try to find a solution in open source resource like Hugging Face and try to use it for this specific language. But for us, it was solved by releases more new LLMs than 3.5. Since GPT-4 and further generation, almost every language LLMs can manage quite well.
Вы так хорошо рассказываете, мне вот интересно, вот точно последний вопрос, правда вам я говорю. Как вот, допустим, ИИ может справляться со сленговыми словами, с разговорными выражениями? Условно, в русском языке есть много сленга, который вряд ли переведут на английский язык, если не знать сути. Оно дословно переведет. Вот.
We got it. Yes, and this was one of our problems what we faced, and it's solved by additional context. And we even have such ability. Sometimes even second or third language validation, it's not enough for context. For example, as OK button. And you need, as I mentioned before, in PO files, this format have ability to specify comments. And we use such comments for special translators. Sometimes, and it's happening quite often, we need to translate not right way. We need to translate exact translation what we needed in this moment. And it may be not right translation, but it's need for our interface needs. And PO structure and comments above the key in such files, it helps us to transfer more context to LLM. And in that case, LLM can manage with that. If you directly ask LLM, please translate in that way, in that sense, this role, then it will work. It's quite widespread problem in translation that not all write translations can use in your interface, in your project.
Ну все, в принципе, я думаю, можно заканчивать. Спасибо вам большое за ответы. Я думаю, нашим гостям тоже очень понравилось. Вот. Спасибо большое вам.
Спасибо вам. I hope it wasn't boring.
I hope to. Goodbye.
Bye.